We started off today with this starter to see if you remembered how we did addition and subtraction using probability from last class before your long 4-day weekend. And the question was, what's the probability that when I roll a pair of dice, I have an even sum or a sum greater than 9? So we went back to this chart that we made, a table that we made to show all the possible sums when rolling 2 fair dice. And if you notice, half of the numbers are even and half are odd. So 18 out of 36 is the probability I'll roll an even sum. The sum's greater than 9. I put a little dividing diagonal green line here, and these are the 1, 2, 3, 4, 5, 6 sums greater than 9 that I could roll, and that's 636. And if you add that, we have 24 out of 36. And now we have to subtract the overlap. These four numbers are both even and greater than 9. So this is our overlap. We've counted these numbers twice. We counted them as part of the 18 and as part of the 6. So we have to subtract these 36 of the outcomes. So we had 36 minus 4 is 36, and then 36 you can simplify to lowest terms by dividing them both by 4, and we get 5/9. So the answer to the question was 5/9, and that was our starter. And you guys could do it, but you need a little prompting from me, so you quite don't have that down yet, but you're getting there. Okay, today we really work with geometric constructions, and remember these are the only tools you can use when you make a geometric construction. This is an example of a construction, and you may not use any of the numbers. We call it a straight edge because you're just using the straight edge on the ruler, and you're not using any numbers on the compass. We're simply using a straight edge compass and your pencil to make geometric constructions. So we just started very basically today by copying line segments and using an addition and subtraction to make different line segments and to create triangles. But I showed you a lot of the artwork I have in class that is actually work produced by students doing really complex geometric constructions throughout the years. And I just asked how. Well, you need a given segment to be able to copy one. So the ones we copied are on page 335 in your book. And then I just had you read that page to find out, how long have people been doing this and what culture started this? And you guys found out that the Greeks have been doing this for 2,300 years. So this goes way back in time. So we started off by just copying segment D. And I said you always begin by drawing a working line about a third of the way down your paper. So we used the straight edge to make our working line. And then we used our compass, and we put our center of our compass, which is a sharp point, on the left side of D. And we opened our compass to be the length of D. So we put the pencil on the other end, and we moved our compass and put our compass on point P, and we drew an arc. And because that arc length, this PQ distance from P to the arc is the same as the length of D. I know that PQ, the distance from P to Q, is equal to 4. So we began with a working line, we established point P, and we used that as our left end, and then we used our compass to find where Q is. Okay, then we had to construct a line segment 5 units long. So I walked you through this. So again, we started with our working line, we established point P, we put our compass on the left end of C and our pencil on the right end of C, and we put our center here, and we made our arc, and that was 3 units long. We called that Q. Then we measured with our compass the length of the 2-unit segment B. We put our center on Q and drew this arc and called that R, and we know that that's 2 because it matches B. This is 3 because it matches C, and now we know the distance from P to R is 5 because 3 plus 2 is 5. Okay, then we did some subtraction. You had to construct a line segment of a length of D minus A. So we threw out the numbers here because we're just now using, uh-oh, my A disappeared. Hold on, let me pull this back here. Now we're just using, A and D. So get rid of the 1 unit. We don't need C, we don't need B. We're only going to use D and A. So we began, you have to have something to subtract from. So we started with our working line, our point P, and we copied D using our compass. We copied D the same way we've done the other problems by putting it on the left side, opening it up to the length of D, etc. We put our left end here, and we mark this red arc. So this PQ, it matches D. Then we had to subtract A, so we turned our compass around and we measured the length of our small little segment A. We get rid of the numbers now because D and A could be anything. They don't have to be 4 and 1 because I didn't want you just to copy C. And then we put our sharp point, our center of our circle, on Q, and we drew this arc here, and mine is green. And then we want to take that part out. So we can do a number of things. I can use my highlighter, and I can highlight the length from P to R because, whoopsie, uh-oh, that was not good. I hit something here. So I want, again, sorry about that, the length from P to R. So I'm going to draw a line from P to R. Okay, and that usually straightens after I've done it. Yes, it did. Great. All right, and then back to my pen, back to red. So here's D again. Kind of took some of that out, and this was my P. So the highlighted part, PR, is equal to D minus A. D was all of PQ, A is RQ. We took that out, so all we're left with is length of P to R, which is equal to D minus A. This is the algebraic representation of this length using variables, and this is our geometric distance from P to R. All right. Then you had to construct a line segment 7 units long on your own, and you guys knew to copy PQ, use Q as your center, and copy QR. Okay, so D, this segment here was 4 units, so that's where this came from. This matches D. This matches C, which was 3 units, and now we know P to R is 7 units long. So that was just practice. Okay, then we made a triangle. So you always begin with the longest side of your triangle when you construct it. It's the easiest that way. So you copied D right here, so PQ is 4. And then we copied C, and we put our center on P, and we drew our arc up here. And what we're looking for is we know that any point on this arc to P is equal to 3, because these are all radius. These are all radii, plural of radiuses, from P to this arc. Then we measured the 2-segment line, B. We put our center on Q, and we drew the green arc. And we know that the distance from the green arc to Q, those are all the same radius. They're all 2. So all we have to find is this point of intersection, because QR is 2, and PR at this point is 3, and that's my triangle with lengths 2, 3, and 4. So again, you start with the longest side. You draw an arc that copies the 3-segment length here. Draw an arc that copies the 2-segment length here, and the point of intersection is where I want to make my triangle. And then we just use our straight edge to connect RQ and RP. And then we have our triangle. Okay, we did the same thing with this isosceles triangle. You drew segment C, which is 3 units long. We measured segment B and drew an arc from P and the same arc from Q, and the point of intersection is where we made our triangle. Then we used our straight edge to connect RQ and PQ, and now we have a triangle. Okay, and then you tried one yourself. You tried making a triangle that had side lengths of 1, 2, and 4. So everybody did their 4, and then when you did your length of 2 and your length of 1, you found that, uh-oh, they don't intersect. We have a gap. And the reason why we have that gap is it's impossible to make a triangle out of sides that are 1, 2, and 4. So you can see that the 1 and the 2 are just too short. So what you guys discovered through doing a little more work in class is that the sum of any 2 short sides of a triangle have to be longer than the 3rd side, or we'll get a gap and we can't make a triangle. So if I would have made this 3, then I could make a triangle. I can't have it be 2 because 2 plus 2 will be 4, and I'll still have them intersecting right here. I need it to be a little longer so I can pull these 2 segments up and get a triangle. So these just have to add up to a number that's bigger than 4. So 2 plus 2.5 would work. I would have no gap and they would intersect. So as long as the 2 short sides, the 1 and the 2, add up to something longer than 4, we can make a triangle. Otherwise, we can't. All right, and then because of map testing, period 3, your assignment's on Moodle. Periods 4 and 6, this was your assignment. Make sure you use your own compass at home. Some of you checked one out for me. And that's it. See you tomorrow at Student-Led Conferences, I hope.